Hello everyone, this is Uchal Bhattacharya and welcome to Generative AI in Enterprise. This is the episode number 6 of this particular meetup group. Let me share my screen real quick to get all of us started, and then I'll quickly hand over to our speaker of the day. So here you go. Generative AI in Enterprise, episode number 6, and today's topic is vector search using MongoDB. I'm Ujjwal Bhattacharya, and I'm running this Generative AI in Enterprise meetup group for the last couple of months. And all these videos will be recorded and shared in the YouTube channel called Curious Circuit. Today, my guest is Nitin Kumar, a senior AI ML engineer. And let's see what we have next. Agenda. Agenda is, of course, introduction, disclaimer, housekeeping, participant introduction. I'll hand it over to Nitin, and then after that, or within the session itself, like we can have Q&A session, open flow discussion, in-depth discussion, as well as sharing our experiences and networking. This is how you can connect me or Nitin over LinkedIn, and the session is being recorded and it will be available in the YouTube channel Curious Circuit. Disclaimer, none of these opinions expressed in the meeting is related to my employer, and this is completely solely my own interest and curiosity. Technical checks. Microphone. I have purposefully kept the microphone mute because there were some Zoom bombings last week, so wanted to avoid that. For today, camera is optional, but we would like to see you, so please feel free to turn on your camera. Participating, you can use the raise hand option in Zoom, also the chat function. We are trying to wrap this up by 7:40, but we'll see. And here you go, Generative AI using MongoDB and vector search. So over to you, Nitin.
Yeah, thank you so much everyone for joining this session. I would like to add few more lines, so that you will understand more about my profile, my experience. From there, I'll go ahead.
Absolutely.
As you have seen the profile that was shared by Ujjwal, it's senior AI ML engineer. It was my, previous profile. Currently, I'm working with Cognizant as a project manager since last 2 years in AIA domain only. So, and in last 2 years, I have built around 5 generative AI use cases, built or supported for different clients, inside Cognizant only. And currently, I'm also the part of one of the major engagements for generative AI. So I have a deep knowledge on generative AI on different databases, just like Postgres, Postgres, MongoDB, and Pinecone vector databases that I have used in different use cases. So I have a good understanding of generative AI. And with that, I would like to start this session. And, if you have any question, anything, feel free to ask me as part of your, this learning session. So let me know if you can see my screen.
Yeah, we can.
Okay, great. So I have prepared this PPT yesterday only. So, but it may not be very good, but we can start from here. So what we are going to cover in this particular session, first is, the introduction to generative AI. Most of us, I think, are familiar with what is generative AI, but we'll talk in very short. Then, from the architecture perspective, what is the approach that we will be following these days, and what could be the futuristic architectural approach that we'll discuss. Then, in terms of vector databases. What are the options and why we should choose the MongoDB one? Then we'll discuss on the different processes that we usually do in the generative AI when we are building any of the use case, like what are the chunking strategies, embedding strategies, and other thing. Uh, we'll also discuss about the similarity search, which is one of the most I would say the power of generative AI. So what is similarity search, how it works, and how it gives the you know a uniqueness to the generative AI solutions. Then we leverage the MongoDB at last vector search, and how we can do that. So we'll have a kind of a demo for this MongoDB search, how it works and how we can leverage it. So these all things we are going to cover. So moving on to the first thing. If I talk about the architectural side, so this is very, very high overview I find somewhere. The architecture, now we will be using what we are going to use. We are going to use some non-AI components and some AI models. This was kind of a 2 years back data when we just build the AI models for some specific task, just like we need to detect any object. So we just make the object detection model, and that model we utilize in, that model we deploy somewhere and we start utilizing it. So we use some AI models and non-AI components to build up the final architecture. And now what we are going to use, we are using some fewer AI models and some non-AI components with the foundation model. So that's, coming soon, or even now we are using, but in the futuristic way, if we will talk about, so, chain of foundations model and then fewer AI and non-AI components would be there. Uh, Chain of foundation models means there could be multiple models, and fewer AI and non-AI components means if we are deploying our model in any of the cloud, then we need to use those cloud services. Just like if I talk about the AWS, if you have idea, we need to write some function, write something. So we are going to use the AWS Lambda functions, or probably AWS Glue or some other services. So some cloud services we are going to use with some of our AI models that we are going to develop. Now, how we are developing the AI models? Maybe with the traditional AI ML technique, or with the generative AI, right? So this is a kind of very high level overview of the architecture. Now, how we are improving this usefulness of large language models. So for that, mm, uh, from this, I think this is traditional AI ML models, just like we usually, train. Because what my understanding is, AI and ML is in existence since last 9 to 10 years. Somewhere in 2013-14, the AI and ML field was introduced. So since then, we are making multiple models on different algorithms like supervised, unsupervised, all the reinforcement learning. So, on different algorithm of supervised learning, we are going to use to build the AI models. And then, uh, you know, ex uh, from this, this was the previous kind of a thing that we are going to follow to build the model. Now, how we are going to, you know, add, uh, you know, uh, in those models, we are going to add some specific data. Maybe, some if we are building a project for a customer, suppose the customer is from some elevator company, then we are going to add some specific data of that particular elevator company to build kind of a customized model for the particular client, right? And now when LLM was introduced, so it gave the boom to that particular, the approach that we are going to use to build the model. Let me go to some other slide. These are some generic one. I just added them just to understand things. Yeah. Now, if I talk about how generative AI model works, generally I have divided them in two different part. The one is one kind of model that we generate that we build in the generative AI, where we upload the document live, and the second one we don't upload the model live. I mean, we have some knowledge articles, some big information, large documents of the organization that we are going to process with the generative AI. So what we do first, non-live vector data processing. What is this? Suppose we have tons of TVs of data, data in TBs, all GBs, I mean large number of data. On live thing, we cannot proceed those data. So we just take the whole data, do the processing of that data, and save in some of the vector DB. Processing means, suppose there's only PDF files, or there may be multiple format of files, but suppose if we are having only one kind of file, that is PDF, then we would like to pre-process those files. Pre-process means in terms of extraction the information from the PDF, we need to filter out uh, some PDF on basis of their content. If all the PDF are not uniform, we have to take care of this. When I'm saying content, maybe some PDF containing only text, some containing images and text, some containing only table inside the PDFs. So there may be different data types, right? So we have to first filter that out. What is the useful documents for the use case that we are going to build? After filtering that out, we need to process them. What is the process? I'll explain in the next slide. So after that pre-processing, we will save the data in the vector database. Why we prefer the vector database in terms of the traditional database? That's one of the major point we need to understand, because vector databases are fast and uh, you know very quick, reliable, secure in all the way. Why they are secure? Because we are saving the data in the embedded format, in the vector format, so they are fast and secure. Now, let me explain this particular architecture for non-live data, where we are not uploading the data live. So we have some data, proprietary data, that we are passing through some embedding model, maybe ADA 002. There are multiple embedding model. We can use any. Generally, the most famous one is ADA 002. By passing to the embedding model, we convert the data into the vector format, and then we save in the vector database. Now, if any user is asking any question, that question will also get passed through the embedding model. So the question will get converted into the vector format. And then that question we will, the answer we will search of that question in the given vector database. So where it's just like a dictionary we have. And now we are trying to understand, what is ABC, or what is, any information we are trying to extract out of the whole database. So once we do the similarity search in this database, we got some chunks on basis of the similarity score, or we can say the confidence score. Suppose it pick 5 different chunks. Those chunks we will send to the uh, LLM. In LLM, while we are sending to the LLM, we first do the prompt engineering. So in the prompt engineering, we just guide the model how to how LLM should behave. Behave means there are different prompt engineering techniques. We'll talk in very short in next slides. And once uh, after this prompt engineering, we send the those chunks to the LLM, and then LLM generate the relevant answer and send to the final UI screen or the output screen. This happens in the non-live system. In the live system, what happens? Sometimes if we are uploading more documents, it may take some time because generally in one of the use case where I was uploading the documents, it was generally taking around 8 to 15 seconds. This is my personal experience, right? So when we will be uploading up to 10 files. So when we are uploading the files in the live session, then it need to be, pre-process the data, then save the data in the vector DB, then only user can ask the question. So in the live, it generally take little longer time, but we get the same accuracy for both the systems. So generally, the Gen AI system can be divided into two categories, live and non-live, processing. Now, integration proprietary data into an LLM. I think there's the same thing in a different way. We will be having some queries, passing it through the embedding model, and then that data will be saved in some vector DB. That data may be any metadata and app data, audio files, image files, text files, anything, right? Then we'll do the prompt engineering, pass it to the LLM, and then uh, we'll get the specific answer for the query that was asked by the user. Now, why this vector databases are so popular? This is the little bit old data of I think last year. But just to understand the popularity of the vector database, I have shown you this graph, so that we'll have an understanding. If we are going to understand what going to use the vector databases, why it is essential and why we are going to use it. Or now we are talking about in this particular session why we are preferring the MongoDB only. So if we'll talk about the relational database, we generally have the property of strong consistency, management security, and integrations, and expressive query language and secondary indexes. So these are some basic property we get in the relational database. And in the non SQL database, in non SQL database, we get some other flexibilities, just like we can scale it, scalability and performance and other things are there. Now with the MongoDB, we have all those properties available. So we have the flexibility, strong consistency, scalability options and everything. So that is why we prefer the MongoDB. I'm just taking it very quick because the session may go beyond time, and we'll spend more time in terms of the demo part. So this is just theoretical part, so not utilizing much time here. Now coming to the data processing, that as I have told you, we have large documents, maybe multiple documents. Then we first do the data filtration part that I have already explained. Filtration means we need to find out the uniform data as well as the relevant data for particular use case. Maybe some document may be useful for use case 1, but not for the use case 2. So for every use case, we have to filter the data correctly. After filtration, we can do the data extraction part. So in the data extraction, what happens, suppose we need to extract only vanilla text. Then we'll use some algorithms, maybe some Python libraries or some extraction tools, just like in Amazon, in AWS, we have AWS Textract. So using the text extract, we can extract the data. But there are some limitations as well. As per my understanding, AWS text extract can extract the data from PDF, from the image files, but it's not that good in Excel files. We cannot extract the correct data from the Excels using the AWS text extract. So for that, we have to use some different Python libraries, to extract the data. Now, when we extract the data, we just divide that into different chunks. Chunks means the, kind of small pieces of the text that we do. Why we divide the data
Hey,
into the chunks?
hey, Nitin, sorry. Since you're the host, can you just once again check if there is someone in the waiting room or not? Because
Oh,
I
I
get,
think I think that you are also the host, so you will be, selecting them all.
yeah, no, I made you the host. Let me quickly reclaim the host and then I'll make you the co-host. I'll try to make you the co-host because there are people pinging me who wants to join but cannot join. I'll just quickly reclaim. Sorry for the interruption, huh?
Yeah, no problem. So where I can.
And then I'll try to make it. Looks fine. Sorry for the interruption. Yeah, there are a couple of people here. Okay. Um, Somehow I'm not able to see the co-host option, so I'll make you host back again. I don't know why, but go ahead, Nathan. Over to you.
Sure. Sure, I'll take care of this. If I'll get any
Yeah,
new
somehow
request, I'll.
I'm not able to see the co-host option. I don't know why, but anyway,
No.
let's move ahead.
Yeah. Uh, I shared my screen. Is it visible now?
Yeah, yeah, yeah.
Yeah. Yeah. So I think we have just till now talked about a bit in a very short term what are the generative AI architectures and the current one and the futuristic one, why we prefer the MongoDB in terms of our vector database selection part, and few things about the generative AI. But from here, I think the major part starts, the data processing part. So data filtration, as we discussed, now the data extraction part. So from a large document, if we are extracting the vanilla text and suppose it's a very large document, we have a large text extracted, then we have to divide that into a different chunk. There are two reasons we divide into the chunks. The one is our LLM has some limitations. Every LLM has a different limitations. If you use the OpenAI ChatGPT 4 or 3.5 or Turbo or something, then probably there's a token limit of I don't remember exactly, but 4096, I guess. Right. But you will use different LLM models, just like Bedrock in AWS or for Google, Bard or something. So for different LLM, there's a different token limits. If you want, I can share that sheet as well. So we do the data extraction. After extraction, we have the limit in the LLM for token. Token limit is nothing, just to generate the answers, how long the answer can be generated and how much data we can pick out for one chunk. So that is the one reason we do the chunking. And the second reason is, uh, suppose I don't want the very long answers, or I want answers to be in limited, words or something. So we put a kind of a restriction that should be the token limit. So these are the two major reasons. So that's a major part of extraction. So after extraction, we do the chunking part. Now, chunking the data. So for chunking, there could be multiple chunking strategies. So that we can understand. For example, there are multiple chunking strategies. Few I can help you with. The one is word label chunking. One is sentence label, right? So what will happen if we have if we have taken, for example, 100 words will be in one token. So this kind of a word label chunking. If I have said like 100 character would be in one chunk. So 100 character means A, B, 1, 2. So these 100 characters will be in one chunk. Similarly, there is a sentence label chunking. So for per 3 sentence, 5 sentence, we are taking individual sentences as per the chunking. So what's the, yeah, I mean, there's some drawbacks and some plus and minuses for this chunking strategy. That is something we need to take care of. What are the plus and minuses for character label and for word label chunking? Suppose we have taken 100 tokens to generate, for one chunk. So what will happen when 100 chunks will over, 100 words will over, the chunk will be completed. So we don't know when the last 100 chunk, 100 word is there, whether it is ending a sentence there or not. Maybe in the middle of a sentence, our chunk will be over, but last sentence will not make any sense because it is half of the part of the sentence. So sometimes character label and the word label chunking are not that uh, that good. So we generally use the paragraph label chunking, but it also depends on the use case to use case. So after data processing part, pre-processing part, when till now we have just did the chunking of the data out of the large documents, we go to the embedding strategy. Embedding strategy is just to vectorize the data and save it in the vector DB. So the objects that you can see here, you can assume it like the chunk 1, chunk 2, and chunk 3. So these are different chunks. We are passing those chunks through the embedding model, and embedding model just convert that into the into these numbers, and these numbers varies from 0 to 1. So you will see different number here. Now, how these numbers are generated, most of us, we can think in this way. How these numbers are generated. Suppose the sentence is, he is a boy, then how these numbers will be generated. So that's I mean, very deep question. So for every different uh, sentence, we have feature table. So for every different that embedding model, in generally, as I've said, we use ADA 002. We had some feature table. In that feature table, we give some number, just like we take example of, for example, I'm taking example of apple and mango. So apple and mango, there are two only words. So for apple, the feature matrix would be the color of the fruit, the size, the weight, or there could be multiple differentiator in terms of parameter for apple and mango. So for suppose if I talk about the weight and color, so if it's a color based, the matrix will be red. For red, for apple it will be 1, for mango it will be 0, for yellow, for apple it will be 0, for mango it will be 1. So we can say like 0.2 0.2 for apple, 0.1 for mango. So this is how, on basis of the feature matrices, these numerical values are generated, right? So that's the work of the embedding model. How embedding model internally work? that I have given you a glimpse, but not in detail. So finally, whatever the chunks we are having, we are converting that chunks into some, numerical values that we call vector. And these vectors we save in the vector database. So I think till now we discussed two steps: data pre-processing and then embedding the data into the vector databases. Now in vector database, we have this particular data saved. Now what we'll do, we do the similarity search. Similarity search is, most beautiful thing in generative AI. What happened in that? We just send our query to the vector database, and that query will do the similarity search and pick few of the chunks, as I've said. It may be 3 chunks, 5 chunks, or a number of chunks that we can set in the while we are building the generative AI use cases. So generally, the similarity search is of 4 types. Generally, we use cosine or Euclidean. Mostly in my, I have developed around 5 use cases till now. On 6th I'm working. So till now, I generally used in 4 of the use case cosine similarity search. Cosine similarity search. In one of the use case, I use Euclidean based on the use case to use case. And Manhattan and this another one we rarely use. So, but also we need to know these similarity search as well. So what happened in similarity search, as I have explained, that determines the relation between the term and the overall meaning. So suppose I have asked one question, uh, who is the boy? And then it will find some relevant chunks nearby this question. Maybe he is Ram, he is XYG, he is John or something. So he'll pick few of the chunks, send it to the LLM, and LLM will generate the final response. Now, to generate the final response, before that we have one major task to do. That's prompt engineering, right? So for the prompt engineering part, what is prompt engineering? Prompt engineering is just like an instructor, just like a school teacher. So it teaches the kids how you have to behave and how you need to generate the responses, how you need to answer the queries of user. So this is the work of the prompt engineering. So this process helps Gen AI models to customize as per our requirement. So prompt engineering, generally there are two kind of prompt that we write: the system prompt and the user prompt. And for example, I can tell you one type of prompt could be, suppose if you would like to do some mathematical operations or some calculations, then in the prompt we can provide different steps. First, you need to add those 3 numbers. Then you have to do this division, multiplication, and further steps. So in every we can provide the steps to the as a prompt, just like step 1, step 2, step 3, step 4 that you need to follow. The second kind of prompt could be just like we'll tell to the LLM, just like you are an advisor to one of the traveling agency, and you have to guide the best places for different season or for different month. So that kind of plain text we can provide to the as a prompt to the LLM. So there are multiple prompt engineering techniques that we need to practice while building one of the generative AI model. Now, uh, till now, before I move on, is there do we have any questions till here? Okay. Uh,
Hey, Nitin, can you hear me?
yes, Gaurav, I can.
Thank you. So I put a few questions in the chat. One, MongoDB, is that different from MongoDB Atlas? Because MongoDB, as far as I know, is a document database. Is it the same as a vector database? Can you clarify?
Yeah. Yeah. So MongoDB and MongoDB Atlas is quite different.
Okay,
Uh, yeah, MongoDB Atlas is recently launched. I mean, few years back, 1 or 2, 3 years back. I don't remember the exact launching date, but it is majorly for the to save the vector data, right? It's not the traditional databases.
okay. And
Yeah. This is designed for this, to build these generative AI use cases.
and then what Python libraries do you use for that document extraction and chunking?
Yeah, for document extraction, if I answer, there it depends on the use case and the document type. So, as I have said, if you're working in different cloud environment, maybe GCP, Azure, or AWS, so
Hmm.
there are multiple data extraction tools that you can use. Just for AWS, I have said the Amazon Extract is the one, right? So that we can use, but they support some minimal level of extraction. So we suppose Excel is not supported by the Amazon Extract, so we need to use different Python libraries that we need to Google and figure it out which Python library work best for the extraction.
All right. What about chunking?
Yeah, for chunking, uh, uh, it depends on your experience as well. Suppose you have done 10 projects, then you will get to understand easily which kind of chunking strategy would be useful for the current use case you are working. Whether I should go for the word level chunking or some other level chunking. And suppose if you're not experienced, you are building for the very first time, then obviously you need to do some hit and try. You need to try with first with the word level chunking, then character level chunking. In my first project, I have used character level chunking, and then I moved to the word level chunking, and I stopped at word level chunking, and it was giving the best performance. So it's a hit and try method you need to do.
But which tool has the chunking? Is it all in the
Yeah.
same extraction, or is it a different tool?
No, and there's no different tool. There's a different Python libraries for chunking. You
Different
can use NLTK.
LLT.
NLP is, yeah, but that I used in my use case. But other than that, there are more libraries which you can use. They are more, I think, more robust.
Okay.
Like Tick Token. Tick Token is one of the library that we generally use for chunking.
All right. And then just curious, what vector database is used by ChatGPT?
Uh, there's no vector databases used by any of the LLM. We have to configure in our use case and which one we would like to use. ChatGPT is just a kind of a, API interface. We can connect any of the database with it.
I see. Okay. But by default, when
Um,
as a standard user, when you're going in, isn't it using a vector database for all the data?
yeah, let me tell you, for one client,
Yeah.
initially, I'm telling you with my experience, for the first client, we have used Pinecone Vector with DB, which
Mhm.
is free of cost. You can use one index for free of cost in Pinecone Vector DB. So we use that. But for another client, it was also one of the major clients. So they said they have some security issues, so they cannot use any of the third-party tool, like Pinecone and all. So for them, we used, Postgres as a vector DB for them.
Sounds
So it depends on the client, what their requirement is, and for us as well, I mean, what we are looking for. If we are looking for security, definitely we cannot use a third-party tool. If we are just doing hands-on or for some client where they have no security issues, we can generally go for the Pinecone Vector DB. That is one of the best, uh, for beginning.
okay. Thank you.
Yeah. Ujjwal, I think, yeah, you are again the host, right?
Oh, really? Okay. Let me double check. But while I check that, I think Shiv, you have some question. Oh, sorry.
Hey, can you hear me?
Yep.
Yes,
Yeah.
yes.
I did in my ex company we did have a requirement where we were supposed to implement vector DB. Um, it didn't pan out because that was at the early stages before LLMs got popular. There's not much support on the internet as well at that point. And so speaking on prompt engineering, vector DB search and query, and there's been a recent advancement, especially with LLMs. Have you heard of the concept called as data drift?
Yes, Shiv.
So in order to overcome data drift, the traditional methodology was that you monitor all the underperforming samples and you retrain your model on some scheduled intervals of time. And since that is a little inefficient, I recently read this paper called Retrieval Augmented Generation, which is basically rather than you training your LLM at every given few months or weeks. And in order to improve your LLM responses as well, you directly hit or you query the internet. It could be the internet or it could be your database as well. So just wanted to understand, since you deal with proprietary data, I understand it won't be there on the internet, but let's say you're building something for a more general use case, right? So how can you use vector DBs and like let's say vector DB is sort of like a buffer database wherein you keep querying the internet and so that you reduce the latency time. And yeah, how exactly can you use retrieval augmented generation with this?
Okay. So my understanding is for your question, you you are kind of slightly new to the vector databases, and you would like to understand how vector databases work in terms of uh, in terms of building the applications and all, right? I would say like for general use cases, as I've said, you can use one Pinecone Vector DB. I don't see here the chat option. Yeah, there is. Let me type the name. So Pinecone Vector DB is one of the very famous vector databases to build the uh, to build the basic solutions or to build the even the advanced solutions. So I'm sorry, I forget the context of your
No,
question.
so yeah, I mainly wanted to ask you is how, if you've heard of retrieval augmented generation, that is, if not,
Yes.
it's fine. So how exactly can you use retrieval augmented generation with vector databases? So I like from a high level, what I understand is you can query the internet, again, like clean the data from the internet and then store it in your vector DB. So in order to reduce the latency time in which like you rather than querying the internet directly, you can hit the vector DB and get enhance your responses. And your vector DB is something which will keep getting updated as and when you let's say you have a scheduled process which would hit the World Wide Web or any given list of websites on the internet to get information from and you keep updating it. So I just wanted to understand how vector DBs can be coupled with retrieval augmented generation. And I have a follow-up question as well. So I'm not sure if you're allowed to say this, but how do you have any applications in which you try to solve for your clients? Because my old company was into document information extraction, so we tried using vector DBs for it. So yeah, like if you have any specific problem statements which you solve in NLP and vector DB. So yeah, these are the two questions.
Okay, got it. So to answer your these questions, I would say vector DB. We generally update when required, and if we are scheduling a kind of a job in which the data will automatically get updated in every few months or in some interval, that is fine. But generally, the purpose of building these model is for some custom data or for some custom use, right? For some custom use. So if we have some data, for example, in most of the company, we have the ticketing system, right? If any of the employee or any of the associate is not uh, facing some issues, they will raise the ticket to the support team, and then they do the follow-ups of those particular tickets. So so we have a custom data if we would like to build the solution on top of that. Right. The custom data is kind of their ticketing files and all the log files and other thing. So we have to train the data on that particular data set only. Now, your leadership or you have to decide in what interval we need to update that data, and that's a one-time job actually, right? One-time job in every 6 months, 2 months, 1 month, whatever the scheduled time we are selecting. So vector data and mm, so this is how we use the vector data. Now, how it is uh, used with the RAG architecture, you were saying, right?
Yeah.
Yeah. So for the RAG architecture, what happens? Let me again share my screen. I hope you can see, right?
Yep.
Yes.
Yeah. So if you'll see this RAG architecture, in this particular slide, how we are utilizing the vector data prompt engineering. Yeah. So this part. This the query that user has asked, we are passing it through the embedding model, and that vector will be doing some search in this particular vector database. So this part, I would say, we have vectorized and saved in some of the vector DB, and we can use any of the vector databases here, as I've said. For example, right now I'm taking Pinecone vector DB as a reference because that's the free one, and other databases are costly. So in this RAG architecture, that Pinecone vector databases, uh, you know, would be used, and here the query that we are asking, it is generating some it is doing the similarity search and generating few chunks, right? So those chunks we will be again sending to the LLM. These selected chunks we are sending to the LLM. So finally, what my point is, this is how vector databases are used, because if we don't have these vector databases in the RAG architecture, as you know, the issue of taking longer time and generating relevant or selecting the relevant chunk would be a kind of a tough task for this. So this is how the vector databases are essential for this RAG architecture, especially in the Gen AI applications.
One last
Hey,
question.
sorry,
Yeah,
Sarish. Nitin,
please go
just
ahead.
a time check. We are almost at time. So if you want to, cover your slides and kind of like your content and shift, maybe if you can hold off with the question,
Yeah,
you
yeah,
can
sure.
always connect
Yeah.
with Nitin on LinkedIn,
Yeah,
right?
yeah, sure. Yeah.
And kind of like have that conversation.
Yeah,
So
no
sorry
worries.
for that shift.
No, no problem. Yeah.
Yeah. And feel free to ask me any question. If I would not be able to answer right away, I'll definitely get back to you on that.
Or
So,
maybe like, we can have a second session also, Nitin, if you are okay with that. To
yeah, sure.
go more in depth.
Yeah, correct. So even this MongoDB, even I'm using very recently because as I've said in previous project, in previous use cases, I have used a different kind of vector databases. Of my first use case, I used Pinecone Vector DB only because it was free and all. So yeah, you will go to the MongoDB, and now what I'm going to explain, that particular part. The vector data, right? How you can use it, right? So especially with the MongoDB. So as you know, like MongoDB is a managed service and it's a cloud service as well. Cloud service means we don't need to install it in local or we don't do anything with this local. So we have this goodness, and it's also no SQL databases. So no need to define the schema, or we can change the schema in running time. So that is kind of a positive points about this MongoDB at last. Now, coming to, I'm showing you that like how you can create the vector database in MongoDB. So that's a quite easy step. First, you will go to the mongodb.com. And if you are new, suppose I'm using I'm using the first time with my email ID. So I'll click on try free. I'm using my old Gmail ID here. Sign up with Google. So I've just clicked on it. Oh, I think I'm already logged in from my current mail ID, nksharma.tech@gmail.com. So what I'll do, I'll just log it out from here and will show you again. Like, or you don't have a sign up. Uh, So I'm just logging, just creating one account here. So it said it has sent me a email on this email ID. So for that, I'm going to this my Gmail ID. This is dr.nitinjolly. I'll be expecting one email. Yeah, I got it. I'll click on this verify button. I'm in this normal process. Once it is verified, email successfully verified, I'll go here. And then I'll again go to the MongoDB. I'll sign in this time. So I'm signing in with this email ID. Remind me later for multi-factor authentication. Yeah, so I landed on this page. Now what I'll do, I'll just deploy I'll create a cluster here. So for that, I'll create the data set here. So for that, we have a few options to deploy our database here. There are three options, the 1, 2, and 3. So I'm selecting the free one. Even with the free one, we can, just try our hands. We can use any of the cloud service provider. Currently, I'm selecting this Azure one here. Then I can provide the name to this cluster. For example, I'm providing Nitin, for example, and then I'll click on create. Bicycle, it is asking, I'm just
Very tricky.
security, some issues. I mean, these are the one-time step only,
Correct.
right? So now the username is Dr. Nitin Jolly, and the password for just testing, I'm setting up tested 123. Then create user. I'll also add my current IP address here. It is already added. This step is required because later it will ask you most of the time why add your IP address, because we are connecting this with our local environment. So to connect this, we have to provide this. Now I will click finish and close. It will take a few seconds of time and it will be there. Now, so yeah, you have deployed database. Now go to the database. You'll see some data here, but as of now, we have not taken any custom data. So for that, we can go to the browse collections, and here we can add my own data or load a sample data. So currently I'm just clicking on load sample data. Right. Or I can click on add on my data, and I can provide my data as well. Just to save the time and to understand the process, I'm clicking on this particular thing. Then after, once it is, the loading will take around 1 minute of time, I guess. And these insert, update, and delete, all other options can be performed using the shell script. So until that was working in backend. Let it run. So until it is loading, I'm telling you the next step. We need to connect this with our local. So what we need to do, we will go to first we'll go to one of the link, that is mongodb.com/ yeah, that's the one. Correct. Try download shell. So this link I can paste you in the chat itself. There's a free tool that you can download by selecting the configuration of your system. So you can click on MSI and can download this package. As I have already downloaded, and install. So for example, I'm downloading it again. It will take around 5 to 10 seconds of time. Yeah. So it's done. Now I'm clicking on it. Meanwhile, our data set is getting created. Okay. I'll click on next because I already installed. So it is asking for repair. I'm just doing it now. It will not take much time, then done. Now I'm again moving to this particular data. It is still loading. I can, once I install that particular extension, I'll go to the command prompt. And in the command prompt, I'll type the command mongo sh. If I'll be getting, this kind of message, even the some error in the connection, that is fine. But it seems like we have installed that tool and it is integrated nicely. So this is one thing. Our sample data set successfully loaded. Now what I'll do, I'll just click on this connect button. I'll go to the shell and then I'll copy this particular code. Run your connection string in your command line. Copy this, close this, go to command line, paste it. Now it will ask to enter the password. I have selected test@123 and see it's connected now. Now, just few more things I'll show, then I'll take up the question. So sorry, I think we are slightly late by 5 minutes. It will take around 5 more minutes.
It's okay.
Is
Yeah,
that
let's
fine?
complete it. Yeah, let's complete it.
Sure. Yeah, once this is done, you can go to the network accesses, and in the network access, you can add one more IP. This time you can select allow access from anywhere, so that anytime if you are accessing this, it will not give any issue. But this is just for testing purpose. I will not recommend if you'll make this for any of the client project or any of the security project where security is a concern. So just for this particular demo, I have clicked on this particular network access because I was seeing okay, it works. Okay, great. So now what I can do here is I can see the databases that I have. So I'll click on show DBs. So these are the different databases has been created. So you can see there are many. So for example, I can select any of them. I'm selecting use sample. For example, I am selecting this mflix underscore mflix. Okay, so now we are switched to here. Now, if I would like to see the data of this, I'll click on show collections. So a different folder, comments, movies, sessions, theater, and all. So if I like to go in any of the these folder, what I'll do, I'll just do db dot. If I would like to go for users, I'll click on users dot find, enter. So this is the data we have in the user as of now. Or if I would like to go to other one is comments. Okay, I can go to comments. So this is the data we have in the comment section. So yeah, this is how we can do. Now suppose I would like to add some data in this comments one, right? In these collections, suppose I can go to any of these folder and I would like to add some data. So right now we are in let me go to movies. What is there? This is the sample data, so even I don't know what's inside that. Yeah. So now, what I can do,
I have a question. So where is,
just
you
yeah.
know, so you're showing, how to set up the Mongo database, how to load the data and all those things and how to connect. But where is that, vector search and which one of this is a vector DB or is
Very,
it like,
very good question. Yeah, I'll come to that. Just allow me just 2 more minutes.
okay, yeah, sure.
Yeah. So, I have already written one script here to add the data. What is this script? I'm just adding my name, Nitin Kumar, then last name Sharma, my email ID, my phone number type, cell phone or home and all. So I have just copied this particular code and I'm pasting here. So this is how I'm adding my data in this comments, right? I have inserted one of this particular data. Now, it is there. Now, if I would like to see this, I can go to the, first I'll clear this screen. Then I'll go to this comments and I'll see like this data might be added. There are a lot of tabs. Oh, let me open a new tab. Mm. There would be one additional data set that might have added.
That's okay.
Uh,
Maybe you
uh,
can also look at it in the Atlas, right? Search in Atlas and see. It will show up over there as well, right?
yeah. Okay, yeah. Let me, meanwhile, I'm searching it here. Let me answer for the question I think someone asked, how we will be utilizing it in our use case, right? May I know who asked that question?
I asked it. Ujjwal.
Ujjwal, yeah, sure. So, yeah, so as I have said here, if we will look into this architecture, here we are using MongoDB as our vector database, and we to save this particular data, the embedded data, into the vector DB. If we are using the Pinecone, we are using to.
Yeah, but my question was right now, the demo that you're showing, it's not embedded data. It's like regular, data that
Correct.
you're needing, right? It's not like in vector format, 0, 1. So
Okay.
in your demo, like, are you going to show us that how you're inserting vector into like embedding and then storing it into the vector database, or is it not part of the demo? That was my question.
Okay. So for that, yeah, in this demo, we are not going for that, but
Okay. Okay.
yeah, no, but no problem. What happens, as I've told you, the main data that we are inserting or adding or whatever the user data we are having, we have to pass it through the embedding model, right?
Mhm.
So the common embedding model I told you, it's ADA 002. So, I have the code, but not handy with me. ADA 002 is the embedding model that we need to pass, right? Once we'll pass that data from this model, it will be in vector format. Then we will save it in the, that's vector DB.
Okay.
So we have not passed it using the this ADA model as of now. That's
Okay.
the
Yeah,
thing.
I was thinking like you're going to show that as a demo, but that's okay.
Yeah.
Anyway, we are also out of time. So maybe we can do that at some point of time.
Yeah, we can schedule some other session
Yeah,
where I
correct.
think the whole, code I can walk you through how we can
Correct.
convert it in embedding
Yep.
and other thing. Yeah, so now I think if anyone has any question, I can take that up. And what I'll do, I'll share, this particular slide with you as well as the piece of code. And if you need anything else from me, you can reach out to me on my LinkedIn. Right. So that's it.
Awesome. Okay.
Oh,
Thank you
yeah.
so much,
Over to you.
Nitin, for your time. Anyone has any question? Like we'll quickly wrap up with 9:15. So any question, please feel free to like unmute yourself.
Hey, I'm just like following up from where I left off. I'm sorry. So, I just wanted to ask you is, so the embedding model again. So if you update your LLM, and I'm not sure if you have the same model for your embedding and your output LLM, but your embedding stored in the vector database would also change. Let's say, for example, you have a sample X in your database and you have a model checkpoint dated today, and I update the weights of that model checkpoint, let's say a week later. So the same input X wouldn't have the same embedding because the model weights are updated, right? So how do you deal with that is what I wanted to ask you. Was my final question at that point.
Yeah. Okay. Shiv, I think there are some maybe I'm not able to understand your question correctly. Let me still answer you. What you're saying, if I'm not able to understand what you mean by LLM changes, right? Because LLM doesn't change, right? What happens? Whatever the data you are having now, maybe, for example, your data is a sentence, he is a boy. For example, just take this, right? And you are converting this into the vector format using some of the embedding model, right? Now it is converted into the vector format. Now it doesn't matter which LLM you are going to use now or in future. If you are changing, suppose from OpenAI to Bedrock or to some other LLM, it will not
Okay,
matter because the data is same.
okay,
Yeah.
I think I might have confused you a bit. What I meant was, aren't the weights of the embedding model ever updated, or do they remain the same? So that was what I wanted to ask.
Weights of embedding model gets updated. That's your question?
Yeah, yeah.
Yeah. So
And how
embedding
would that affect the LLM?
Okay, so actually embedding models are the standard models that generally, cannot be customized, cannot be changed. So like ADA 002, that's a standard kind of a model that we don't, update.
Okay. So
But
any
Shiv,
okay.
Just a kind of a
maybe like
converter. Yeah,
yeah, maybe if I want can add, maybe I'll try to give it
please.
another color, right? So basically what you're saying is like if the weights of the embedding model changes, so that means you are what happens if you create a new embedding model, or maybe like OpenAI goes ahead and comes up with a version 2 of the embedding model. Now the weights have changed. So when you're taking this sentence like I am a boy, it gets converted to 1, 2, 3, 4. Now with the version 2 of the embedding model, now it's like no more 1, 2, 3, 4. It's like 3, 4, 5, 6.
Yeah,
How do you deal with that? So that's where
yeah,
it's trying to. So just like the OpenAI LLM version can change. What happens if the embedding version also changes? Like today you have
yeah,
ADA 002, and then tomorrow OpenAI releases ADA 002.1. Now the weights have changed. Now the vector definition also has changed. So now the responses might be different. So earlier it was like dog was related to a cat, which is like animal. Now what happens if a dog and a cat is a little bit far away, right? So, is that the question that you're
yeah.
trying to?
That's what I want. That's what I wanted to ask. Yeah, exactly. Yeah.
Yeah. Thanks, Ujjwal. Thanks, Shiv.
Yeah,
Yeah.
I don't know the answer, but maybe Nathan, you can.
If you feel the answer is long stretched, I can probably reach out to you via LinkedIn. Yeah, and then like you can give your answer there. Yeah, I don't want to hold people up, and it's early morning for you as well. So yeah, I don't want to hold people up. So yeah,
Sure, anytime.
yeah.
Anyone else? We'll just wrap up. 9:19. We are 20 minutes over. Okay. I think we are good. Nitin, really appreciate you taking the time out from your busy schedule. Everyone is busy, and you are excited, and you took the time out in the early morning to share some of your knowledge and your thought process with this group over here in New Jersey. So really appreciate, and thank you so much from New Jersey.
Thank you, Ujjwal, for organizing this and having me as a speaker. And I'm really, it's my great, I would say pleasure to be, the part of this meeting and to share my knowledge with all of you guys. Thank you, everyone. Thank
So
you,
see
Ujjwal.
you until next
Thank
week. Take care.
Right.
Bye bye.
See you.
Thank you,
Thank you,
Nitin.
Nathan. Thank you, Ujjwal.